Hey everybody, and welcome back. Or if it's your first time here, welcome to this channel. I'm David Townsend. This is the Netcademy, where we are learning networks together. And on this video, what I'm going to go through is the theory only. There's no lab, but the theory on BGP, or Border Gateway Protocol communities. Now, BGP communities are a huge topic. I can't state that enough. And a lot of people think that BGP communities are only associated with BGP, but they're not. You can actually associate communities with other protocols other than BGP. You could do it with static routing, you could do it with aggregate routing, you can even apply some kind of tag to OSPF, ISIS, and then use those community tags to import them into BGP. So as you can see, just from what I just said, communities is a huge topic, and what we're going to do and go through on this video are what are these communities, how is it actually represented from a syntax, from a command kind of feel, what does it actually look like, and when we look at the BGP community, what are those different parts? What are the BGP communities in terms of what are the different types of BGP communities? So really we're going to go through the theory, and that is very important because we need to understand that before we actually go into the lab, into Juniper Junos, and start configuring the BGP communities themselves. So with that being said, let's actually go straight into the theory now. But before we actually do so, I just want to ask, if you like this video, if you like the content that I actually create, please give it a like. Please subscribe. Any questions or comments, let me know down in the comments box. I love hearing from you guys. Other than that, let's just get straight into the theory. So here we go. Let's get straight onto the theory. So what is a BGP community? Well, in a single sentence, if I was to summarize what a BGP community is, it would be a group of destinations that share a common property. That's basically what a community is it's allowing on any router, but specifically in this case Juniper EX switches, Juniper MX routers, so on and so forth, to assign a particular value or values, we'll come on to that in just a bit, so that other routers recognize that when they receive these routes, these route updates, if there is this community tag associated to those routes or that route, they know that they need to give some kind of treatment to those updates, specifically those BGP updates. So what are those kind of treatments that we can do when a router receives a community value, a community tag? Well, an obvious one is that we want to accept those community tags. We want to accept that BGP update with those network layer reachability information, or NLRIs. This is all about NLRIs at the end of the day. We want to accept that into our BGP routing table, and if it all passes and everything's accepted, we then want to put that into the routing table, ideally itself. So accept is very straightforward. And if we've got an accept, then that stands to reason that there's going to be a reject. We can reject BGP updates with a specific community tag or tags for a NLRI and actually just discard those updates, those packets themselves. We don't have to have that in the BGP routing table, and certainly not in the routing table itself. So we can accept, fine, into the BGP table, maybe into the routing table. We can reject, not even going to go into the BGP routing table, certainly not into the routing table. But what are the other two types of treatments that we can give to communities? Preference. The penultimate one here is actually we need to give, or we can give, some kind of preference to a community tag over another community tag, or maybe from a community tag to a non-community tag. Now that preference doesn't necessarily mean it's just more preferred, because that's very generic. What that means is we can actually assign maybe a higher local preference for that community tag and all that NLRI information that's contained in that BGP update message. You can even manipulate and change and alter that AS path. Remember, this is all coming back to the BGP path preference, the path selection process. If you don't know what that is, here's a link, please check it out. But this is how we can use community values to give some kind of preference over a set of community values over another set of community values, or even a BGP update message that doesn't have any community values associated to it whatsoever. So we've got accept, we've got reject, we've got preference, and what we want to do in that can obviously differ quite significantly. And the last and final one is redistribution. When a router receives a BGP update message for that NLRI, again the network layer reachability information that's contained in that BGP packet, we can, using those tags, those values, that community value itself, say, we want to accept this, I want to give it some kind of preference, but I also then want to redistribute that into maybe a VRF or virtual routing function or forwarding table. Or maybe I want to import or redistribute that into a other type of routing protocol like OSPF. There's lots that we can do with the redistribution. But in general, one thing to take away here is that when we're talking about communities, BGP communities, we're really referring to a set of destinations, or maybe just even one destination, and it has a set of common properties associated to it. And as such, what we can do through communities is traffic engineering. You could probably see it already. You probably got that feel from what I was explaining. Through BGP communities, we can do traffic engineering, really through that accept and then doing that preference, changing local preference, maybe manipulating the AES path, prepending it, making it longer, making it shorter, i.e. more preferred over other values, maybe changing the multi-exit discriminator or MED or anything else in that BGP path selection process. That allows us to do a lot of traffic engineering. So even though communities are, from a high level, a very straightforward thing, they actually have a lot of power to them. But what does a BGP community actually look like? First, you need to know there are two types of BGP communities. There are standard and also there are extended. Now for this video, for this vlog I think it's called, we're really just going to go through standard. I will touch briefly on what extended are, but before I even start talking about extended, I need to do a lot more research on what those extended communities are. It's obviously a lot more to them. But from a standard point of view, what we have is a 32-bit or 4-byte identifier. So it almost sounds like it's going to be the same as an IPv4 address, because an IPv4 address is 32 bits or 4 bytes. But it's not. It's actually got 2 parts to it, whereas an IPv4 address actually has 4 octets or 4 parts to it. But a standard BGP community will look like this: ASN and then community members. I didn't write it all in there because I ran out of space. But what we've got here is obviously 2 parts. Each part is pretty much going to be even, so we've got 16 bits here and another 16 bits here. Now the ASN actually identifies the autonomous system number that BGP update message, that community at the end of the day, that those associated destinations have actually come from. So say for example a router in ASN 6500 is sending out a BGP update message which is received at another router, another ASN and another router in another ASN, so on and so forth. Doesn't matter how many routers down the line, when that whatever router receives those BGP update messages and all the network layer reachability information we've associated and within that update message, they will see that the ASN is 6500, I think I said. So they can actually identify where this community value actually came from. And don't forget that an ASN is globally unique. So whenever we see a community value, it will be globally unique. And the other part of the standard community format is the community members. Now here you actually state and define is a unique number. So the autonomous system that originated that community value, or maybe added it into that BGP update message, will first define its own autonomous system and then give its own ASN community value. So let's actually put this into an example of what this actually means. Well, when we look at the first 16 bits, which are referring to the autonomous system number, i.e. 6500 in this case, what this means is that the autonomous system number, which is globally unique, has assigned that update message containing the network layer reachability information, or NLRI, is saying that the first portion of that community value is 6500. And thus every router or IP speaking switch along the way, if it's BGP capable, when they receive these BGP update messages, they can see, the NORI is contained with this in update message. There's a community value associated to it, 6500, and it also has this value of 1, 2, 10, 100, 1000, whatever it may be. Now the 1 here could mean anything. It is locally assigned by the autonomous system number. It can mean building 1 in a campus. It can mean network 1. Speaking very easy and generically there, I know, but it's locally assigned. That's the important part there. However, what we also need to take away is that the receiving router, when it receives these community values, is going to accept, reject, do some kind of preference, i.e. manipulation on those BGP update messages, changing the local preference, changing the ASNs, changing the MED, whatever it may be, and doing some kind of redistribution. And you can have more than one community value associated to the same NLRI. So you could have 6500.1, and then you could have right next to it 6500.2 or :2, I should say. There's no real limit on what you can do. You could have lots of community values associated to the same NLRI, but really at the end of the day it's allowing those receiving routers to receive those update messages, see there's a community value associated to that set of destinations, and then doing some kind of treatment to that update message, and based on those community values themselves. So let's put this into a little bit of an example. We're not going to go through a configuration in the lab, but I just want to show you and maybe illustrate, putting the theory into a little bit of practice as to what these BGP community values can actually do from a network diagram perspective. So what we are seeing here is quite a few different networks which have already been set up. We've got Enterprise A here, we've got Enterprise B here, and in between that we've got this great big mess that is the internet, i.e. the 3 different service providers: Internet Service Provider 1, Service Provider 2, and Service Provider 3 in ASN 1, 2 and 3 respectively. But what you don't see is actually what these routers here are actually doing all the way over in Enterprise B. What they are doing is actually injecting a static route to simulate that of a host and injecting that into BGP. So on this router here, which I know is R18, it's got a static route of 18.18.18.18/32, i.e. to simulate that of a host, whatever that host may be, and it's then injecting that into BGP itself. This router down here, which is R19, has 19.19.19.19/32. And guess what? The R20 here has 20/32, obviously 20.20.20.20/32, and R21 here has a 21.21.21.21/32. I'm not going to write it all out, but you get the idea. Every single one of these routers is injecting that static route into BGP. The point being is so there's something there. There's something to see from a realistic point of view. Now what's happening then is that these hosts, these static routes, are going through Service Provider 1 here and all the way through Service Provider 3 and Service Provider 2 here into Enterprise A's location. So all these routers here, they can actually see, we're not going to go into the routing table in this video, but they can actually see this static route here. They could see this route, they could see this route, i.e. the hosts themselves. Now coming back to the BGP communities, why is this of importance? It's important because it allows us to do those types of treatment, i.e. the accept, the reject, the preference, and the redistribution. So let's take, for example, R18 here, which had that 18.18.18.18/32 here. And also this router here, which I think is R20. Yeah, it is, which has the 20.20.20.20/32. What we could do is, as those messages leave the router here, we could assign that BGP community value, which would be 65 200, because it's originating from ASN 65200, with a specific community value within that header itself. So we could just say, for example, 18. But I could also do 65219. And that is associated to this host here, i.e. that static route, as well as this host here and that static route. So we can actually group together that 18.18.18.18/32 and the 19.19.19.19/32 and associate them with these community values themselves. And as this comes through or leaves Enterprise B and goes through Service Provider 1's network and then into Enterprise A, this router here can see, I've received a BGP update message from this router here, and within that I could see the network layer reachability information to get to this route here and this route here, but I can also see these community values associated to that NLRIs, and as such I want to accept that BGP update message. I want to accept those community values, but I also then want to do some kind of local preference maybe. So I can then on this router here change the local preference. So what I could do, just for example, is I could say and I'm just going to tidy the screen up a bit, I've just seen it's got a little bit messy, but say I want to change the local preference on this router here for this route and this route, I could say, and again remember local preference, higher is better. I could say for these two routes which have come through here, I want to give them a local preference of 101. Now what that means is that this router is then going to prefer to get to R18 and R20 here. It's going to prefer this route as opposed to going through this router here, through Service Provider 2, Service Provider 3 and all the way up here. Because don't forget, Enterprise A really has two paths to get to Enterprise B. It could go northbound or it could go southbound. So it's going to prefer this route here, but it's going to keep in its BGP routing table the backup path here. So if this link should go down and just fail, or say Service Provider 1 goes out of business and just drop out the face of the planet, they can then quickly change their BGP routing table and inject this backup path into its routing table itself. Now, in the opposite direction almost, what we could do for these routers, R21 and R19, who have the 19/32 and the 21/32, we could say, as they're leaving this network here, we could say, well, we want to assign to that BGP update message a community value. So that could be 65,219 and 65,221, obviously associating to those two different static routes, i.e. those hosts connected to R19 and R20 respectively. And as it goes through Service Provider 3, out of Service Provider 3, into Service Provider 2, and finally into Enterprise A again, on this router here, it would receive that update message, have the network layer reachability information within that update message, and it would see, I could see within that update message for this route here, and for this route here, it has these community values. Now I want to accept that, and then I want to do the same kind of preferential treatment to these community values. I want to change that local preference, say to be 101. So what does that actually mean from a high level perspective? Well, from a high level perspective, what it would mean for the 18/32 and for the 20/32, Enterprise A from this egress router here is going to prefer this direction, but it will keep this direction here as backup because it changed the preferential treatment to 101, or the local preference, I should say, to 101. Whereas in the opposite direction, for R19 here, which had the 19/32, and for R21 here, which had the 21/32, we assigned those community values, and as it goes through the network here, this router here, the egress router Enterprise A, is going to prefer this direction to get to those destinations itself. that is the traffic engineering. And there's lots that we can do with that preferential treatment, that preferences. We could change local preference, we could change the AS path. There's lots that we can do, but just from a high level, that is why we have community values. Is it allows us to accept those routes, allows us to reject those routes, allows us to manipulate the treatment of those routes and to do some form of traffic engineering, and then to redistribute those routes into another routing protocol such as OSPF, which is actually what's running in this network here. But that is what a community value actually is. That's what it looks like. That's why it actually exists. But there are actually well-known community values which actually serve a specific purpose in itself. And that's what we're going to go through right now. So now let's go through the BGP well-known communities. And there's actually quite a few of these well-known communities, but I'm just going to touch and go through the top 3. Now, depending on vendor, you may call these well-known communities different things, but really they're all serving the same purpose. And also some vendors might support something in terms of one well-known community, and other vendors might support it or might not, because at the end of the day, these well-known communities are not a mandatory, well-known, or even a discretionary BGP update. They're actually optional. So they may or may not be there, and it's not up to any vendor to fully support them all at the end of the day. So that's a big point to actually bear in mind, that is that when it comes to these BGP communities, they are optional. They're not well known, they're not mandatory, they are optional at the end of the day. But what is the first that I'm going to go through? What is the first well-known community? The first one that I want to go through is what's known as no advertise. And this actually differs from the next one, because in the no advertise, we are sending, or the router is sending, a BGP update message referring to network layer reachability information, or NLRIs. And within that, there will be a BGP community or communities. And when that receiving router sees, this BGP update message contains these communities, but they're set to no advertise, that means that it is for my eyes only. Absolutely under no circumstances should I or must I forward on that BGP update message containing those communities or community with set to no advertise onto another router. Doesn't matter if it's iBGP or eBGP, that receiving router is going to treat that community contained within the update message in exactly the same way. I'm not going to forward it on, it's for my eyes only. So why would you actually use a community that is set to no advertise? Well, let's just jump back to the lab and see what is the use case for this no advertise. So here we are back in the lab. So what is the use case for this no advertise BGP well-known community? Well, if we look at it from a service provider's point of view, just to begin with, say just for example, I'm just going to draw here another network here, and let's just call this Enterprise C, just for example. Doesn't matter what the ASN is, the autonomous system, doesn't really matter at this point. But this service provider is peering with this provider edge to the customer edge router. They're doing BGP updates, they're exchanging messages, so on and so forth. And that service provider then needs to advertise to all its other customers, depending on how they want to be set up and how that customer C wants to be connected. The service provider will then connect and advertise Enterprise C to Enterprise A and Enterprise B. Of course, that's just generally how service providers work. They're connecting everything together at the end of the day. But why would we need this no advertise community? Well, in Enterprise C, just for example, you could have hundreds or thousands of network prefixes. NAT, PAT, doesn't matter. Let's just say hundreds or thousands of network prefixes. And what we don't want in that global internet routing table is that table consumed by all these network prefixes. That's not going to be ideal. And typically on the BGP global routing table, you never see anything bigger than a /24, because they're just going to take up more room and they're such small networks in the day. So really /24 is the biggest that you're going to see. But at the end of the day, Enterprise C still needs to be advertised in. So what's the service provider going to do? The service provider is going to advertise to Enterprise A and Enterprise B and anyone else that's connecting to it an aggregate route advertise in the way to Enterprise C. And it will also advertise in a more specific route as well to Enterprise A and Enterprise B. Now, coming back to the no advertise community, when these update messages come from these two routers here to this router here in Enterprise A and to this router here in Enterprise B, they're going to see, service provider 1 is now connected to Enterprise C, and I can get to Enterprise C via ISP1. But what they're not going to do at that point is then advertise in that more specific route, just for example, into Enterprise A, because this router here, this router here, this router here, and all these routers here, they don't need to know about that specific route. So we can set the no advertise on router A, on this router here in Enterprise A, to only advertise in that aggregate route and to not advertise in that specific route itself. So that is actually a use case of why we would have the no advertise, is it allows a router to, for example, receive an aggregate route and a more specific route if it's a customer edge router in this example, but to only forward on that aggregate route, not to forward on the more specific route, whilst also keeping that global routing table as minimal as possible in the service provider network. So that is no advertise, but what's the next? An almost similar sounding anyway, BGP well-known community. This is what's called the no export. Sounds similar, but it's actually quite a bit different in that when a router receives a BGP update message containing a well-known community, and if it's set to no export, that router will forward on to IBGP neighbors that update message. So that update message containing the network layer reachability information, and at the end of the day all those communities, will be forwarded on to IBGP neighbors, but it will not go towards eBGP neighbors, and as such the no export is contained with an ASN only. It does not go from one ASN to another ASN, because we are not allowing a eBGP speaking router to advertise that community which is set to no export to another autonomous system. Because it's set to no export, the no advertise is when that router receives that update message with that no advertised community, that router is not going to send it to anyone, not even IBGP routers in the same autonomous system. With no export, those routers will forward on those update messages containing those communities, those network layer reachability information. It will forward it on to IBGP speaking routers within the same autonomous system, but it will not forward it on to another autonomous system, because that is outside of its own autonomous system. But what is the use case of this? Well, the use case is actually quite similar to what I was explaining early on, in that we've got these routers here, Enterprise B, where we've got R18, R19, R20 and R21, and they each are advertising in an 18.18.18.18/32, a 19.19.19.19/32. You get the point, a 21/32 and a 20/32. Doesn't matter if I got the routers mixed up there, not important. But these are advertising, Enterprise B, the routers here and here are advertising in the 18/32, the 20/32, the 21/32 and the 19/32. They are advertising out of their network through the service provider network all those prefixes, those static routes, those hosts at the end of the day. And as such, Enterprise A can actually see, to get to anyone in Enterprise B, I've got two paths. As I said earlier, I could go northbound or I can go southbound. But why is this important when it comes to the no export? Well, again, let's look at it from a service provider's perspective. Say, for example, service provider 1 here, the link between this router here and this router here goes down. For whatever reason, someone disconnects the fiber, maybe someone, accidentally cuts it, maintenance in high streets cuts through a fiber. This stuff does happen at the end of the day. But for whatever reason, that link goes down. And as such, ISP1 can then see through this router here, I can't get to R18, I can't get to R20, I can't get to R21, I can't get to R19. But what it can see, well, at least via this direction, but what it can see is I can still get to those routers, but I've got to go through Enterprise A's network. And as such, Enterprise A then becomes what's known as a transit network. Now, service provider networks, there's different tiers, of course, but they're big, they're capable, they're designed to send, receive, process, etc. vast amounts of data, vast amounts of packets as quickly as possible. Whereas if you look at an enterprise network, regardless of the size, yes, they're capable, but they're not designed to carry and forward on service providers' traffic. They're different types of networks in the day. And as I said previously, what if this router here has got another enterprise, Enterprise C, and another enterprise here, Enterprise D, just for example, and so on and so forth. And they all want to communicate or send information to Enterprise B. Well, with this link down, ISP1 will see, I can get to Enterprise B via this route here. And as such, that's what I'm going to do. So how can Enterprise A actually stop itself becoming a transit network? And this is where the no export comes into it. On this router here in Enterprise A, what you could do is configure that 18/32, that 19/32, that 20/32, and that 21/32 to be within a BGP community set to no export. So as such, this router here will not forward onto ISP1 that, I know about all these networks here, because then if it did so, it would become a transit network if this link should go down in this example. So it's not going to forward on these messages, and as such, ISP1, when this link goes down, it just sees, okay, this link has gone down, I can't go through Enterprise A's network, I need to get this link back up and running as quickly as possible. In an ideal world, they'll have redundancy here, but we all know how organizations can be with redundancy and resiliency, cost at the end of the day. I won't say any more on that topic. But this is why we have the no export community, is it allows, in this use case, an enterprise to configure itself to still receive in from other service providers in these networks here, which come through these service provider networks. And as such, all these routers know and learn about those networks, but to then not forward on those networks outside of its own autonomous system. And I mentioned that there is 3 that I'm going to talk about in terms of well-known BGP communities. For this, I'm not going to go back to that green board. I'm just going to stay on this display because this isn't going to take too long. The third and final well-known community I want to talk about in the Junos world, this is what it's called, is known as the No Export Sub-Confed or Sub-Confederation. I've not gone through what confederations are just yet at the time and date of me recording this video. I'm going to do that in due course. But we can still go through what a confederation briefly is and what this specifically is in terms of the well-known community. Now for that, I'm actually going to just zoom in a little bit more into Enterprise A's network. And what we can see in Enterprise A, now that I've zoomed in, is there's actually 2 clusters. We've got cluster XXXX here and cluster YYYY there. Now, there's a little bit of a wrong name in here. The clusters are actually referring to these root reflectors here. But this here is actually a confederation. I'm just going to do conf for short. This here, down below, is another confederation. Coming back to the no export sub-confederation, what this means is that this confederation, which contains a root reflector with a specific cluster ID, will have its own autonomous system number. The confederation down at the bottom with this root reflector here will have its own autonomous system number, which differs from the one up here and vice versa. So they are almost viewed as 2 different and independent BGP autonomous systems, even though that they both fall under ASN 65100 for Enterprise A. They're actually 2 different mini ASNs as such, and actually they both peer to each other using eBGP. But coming back to the no export sub-confederation, is say this route reflector here learns of another host. And I'm just going to draw a box here, and just a box. I'm terrible at drawing, so apologies, but that's my drawing for a host actually. But I should have done like a little man or something. Hey, there we go. But if the route reflector here in this confederation, so you just call it ASN1 and this one down here as ASN2, just for ease of use and simplicity and speed. What this confederation will do via the route reflector here, as it's set up, is the route reflector will advertise onto this router here. This host, this network is something here. It will advertise down to this network here, but it will not advertise onto this confederation that this network is here, is connected. The no export sub confederation does not allow in any way confederations to advertise or export learned networks, learned prefixes to another sub confederation. And I did say I was going to touch very briefly on extended communities. And to be honest, at the time of me doing this, this is as much as I know. So this is just what I want to share with you. Extended communities allow more functionality. They give more flexibility to that of a standard or regular BGP community. With the standard or regular BGP community, as I said, they are 4 bytes. But as you can see, an extended community is 8 bytes, so it's twice as big. And what we have within that header of the community is a high, referring to the H here, and a low, referring to the L there. Now what these actually do is they specify the community. Just generally they specify what is that community type, and the value actually provides unique information contained within that BGP update. But why would you actually need an extended community? This all comes back to use case at the end of the day. The regular or standard BGP community was, as I just said, only 4 bytes, whereas the extended community is, as you can see, 8 bytes. And if we look at specific networks like MPLS, multi-protocol label switching, which will be using virtual private networks to segment different customers' traffic to and from each other. When it comes to such a use case, the 4-byte regular or standard BGP community, it's not enough. It doesn't provide enough flavor, it doesn't provide enough flexibility for most of those use cases. Whereas the extended 8-byte BGP community offers a lot more flexibility, offers a lot more flavor, offers a lot more power to those MPLS service providers at the end of the day. And that's not the only reason why you'd be using extended communities. There are EVPNs out there, Ethernet virtual private networks, and so much more as to why you'd be using extended communities. And even within the extended community, we can define route targets, we can define route distinguishers themselves, which are very much still in use in multi-protocol BGP networks, MPLS networks, EVPN networks. So just to make you aware, extended communities offer, from a very high level, more flexibility. They offer more choice, shall I call it, in terms of that value, and even what the high-low values can define in terms of that community type. So that's it, everyone. That is the end of this video. As always, I hope you found that informative. I hope you found it useful. As I said at the very beginning, this is just touching the basics, getting the theory, the initial understanding of what BGP communities are. And as I said, BGP communities, there's actually a lot of them, and we only covered on what I consider to be the top 3 BGP well-known communities, which is the no advertise, the no export, and the no export sub-confederation. But as I said, there are a lot more. But recall and remember, it is an optional part of that BGP update message. Not all vendors have to support it. Not all vendors do support the BGP well-known communities. It is optional at the end of the day. But what we also went through is the use cases as to why we would use no advertise, why we would use no export, why we would use no export sub-confederation. And of course, what does it actually look like in terms of that header, in terms of the ASN and that unique value set by that autonomous system number itself. So again, hope you found that useful. If you have any questions or comments, please let me know down in the comments box. Love hearing from you guys. If you like the video, please subscribe. Until then, thanks for watching.